Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Ladies and gentlemen, tonight I want to take you through the data science project using McDonald data set in actually looking on the factors that are actually affecting something called market capitalization. Ladies and gentlemen, right, without wasting time, let's now start with the project. All right, as I said, that this is a data analysis project for McDonald, where I will actually take you through something called EDA, which is actually called the Exploratory Data Analysis. Actually, with the Exploratory Data Analysis, we'll actually analyze McDonald data set to actually look on the factors that are actually affecting market capitalization when given the financial ratio, when given the financial ratios of this company, which is McDonald. And this data that I'm going to use here, it's available on Kaggle. If you want to get all the data or to get in more information about it, you can kindly go to Kaggle, then use the data set to actually compare it with what I'll be presenting here. Right, without wasting time, ladies and gentlemen, I'll take you through the problem statement where I'll be using Python. All right, in terms of the problem statement, as I said, we are actually going to look on the factors that are actually affecting market capitalization. So one must be able to understand what do you mean by market capitalization. Ladies and gentlemen, market capitalization, it is one of the crucial metrics which is actually interested by most of the investors. Actually, they use it to assess the company size and also in terms of its value. But however, understanding its true implication and how it relates to financial ratios, like what I said now. So we'll be actually talking about financial ratios like price to earning ratio and the others. To actually try to analyze what are the factors that are actually affecting this market capitalization and what do we mean by a market capitalization. All right, without wasting time, ladies and gentlemen, again, we need to be able to know that, okay, fine. In terms of these financial ratios, it remains a challenge for most of the investors. So these problems actually seek to explore actually the definition and the calculation of something called market cap. In other books, they call it a market cap. So how this market cap actually impact investors' decisions as whether when in terms of deciding whether they should invest in a specific company or not. And again, we're going to look at the relationship between the market capitalization and the financial ratios. Actually, we wanted to investigate what are the factors that are actually affecting this market cap and how changes in the market cap can reflect, or yes, a shift in the company value. And actually, what are the key determinants of the market capitalization? What are the factors that are actually affecting market capitalization? And now, how can we calculate this market capitalization? Market capitalization is actually primarily calculated or determined by using two factors. Actually, when we calculate market capitalization, which we call it market cap. It's actually calculated by taking the current stock price, then we multiply by the number of shares, outstanding. So this is the formula for calculating the market cap. But it's not the only formula of calculating market cap. But for now, I'll talk about the same. When we calculate market capitalization, we only take the current stock price of a company and we multiply by the number of shares that are outstanding. So now, this is what we wanted to actually investigate to say, what are the factors that are actually affecting this market capitalization? So we are going to uncover those factors using Python, ladies and gentlemen. So now, this is one of the factors, like market capitalization is one of the metric that investors are actually interested on. But however, there are several other factors that are indirectly influence market capitalization. And the first one being something called company size. Company size also has a huge impact on the market capitalization, and also the industry classification, financial performance of a company, such as looking at on the issue of its sales, and also the issue of the earnings or the net income of a company, and also the issue of investors' sentiments and the market trends also has an impact towards market capitalization. And the other thing is the issue of the dividends payment and something called stock buyback programs. This actually has an impact towards market capitalization. And when companies are actually involving towards something called mergers and acquisition activities. For example, you find that company A has to buy the shares of the company B, where they end up merging. This has a huge impact towards the market capitalization, because when two companies actually, when one company buy the shares of the other, this can have an impact towards the current stock price of that company, and also can have an impact towards the number of shares still outstanding. Obvious, if these are changing, obviously, even the market capitalization will also change. So this has to do with the financial analysis, ladies and gentlemen. Right, actually in this project, we wanted to use McDonald dataset to actually uncover the factors that are actually affecting market capitalization. But however, in this project, we'll focus heavily on the issue of the EDA. We'll use something called the EDA, which is the exploratory data analysis. But in the next project, I'll be taking you through the machine learning. I'll be taking you through the machine learning to actually make predictions, or yes, actually to explore further in terms of the factors that are actually affecting the market capitalization, ladies and gentlemen. Right, without wasting time, let's now move on to the objective of the project. Right, the objective of this data science project is actually to uncover the major determinants of this market capitalization using something called exploratory data analysis, when we are given the financial ratios data set from McDonald, which is available on Kaggle, ladies and gentlemen. So we actually wanted to know what are the major factors that are actually affecting the market capitalization. So which means that in terms of this market capitalization, in terms of the analysis, the market capitalization It's our target variable. It is our target variable. So we'll be actually talking about other futures, which you call them the independent variable. So we actually wanted to compare what are the major factors that are affecting this market capitalization. So we want to actually explore that, ladies and gentlemen, but by using the exploratory data analysis that is to do with data visualization, ladies and gentlemen. So now I will take you through the data descriptions. So according to the McDonald data set from the financial statement, this is the description of the data. In terms of the data set, here are the following. In the data that we are going to especially explore, there is a year column, there is a market capitalization column, which is actually in billion of dollars. So it means it is in US dollar. We'll be also talking about the issue of revenue, which is the revenue in dollars, the earnings, the price to earnings. Actually, they use this revenue and the earnings by using, they actually taken the financial statements. They've taken the financial statement of this company of McDonald, actually on the issue of income statement and the balance sheet. Then they use these income statements and balance sheet to actually compute these ratios. For example, price to earnings. So they've taken the price and they divide by the earnings. And again, price to sales, price to book values, operating margins in terms of percentages, earnings per share of the company, shares that are outstanding, cash on hand, and actually they're also going to use the cash flow statement of McDonald's in actually getting these financial ratios. And again, the issue of dividend yield. And dividend yield, when you talk about the dividend yield, it's actually the dividend divided by the earnings. So this has to do with dividend yield. And again, we have the dividend when the stock split is adjusted, and something called the net assets when we subtracted all the liabilities. And again, the issue of total assets in the company, and this total asset actually are extracted from a balance sheet. They actually extracted from a balance sheet, because balance sheet has to do with asset, owner's equity plus liabilities. So this is actually found in the balance sheet. Total debts of the McDonald company, and also the issue of total liabilities. But however, there are other financial ratios which were not included there. For example, the profitability ratios, such as the return on assets and also the returns on equity. But this has to do with if we wanted to analyze the profitability ratios of this company, but it's not what we're actually interested on. But if in other instances, we can even include that to actually try to check what are the major factors that are actually affecting market capitalism. For example, in terms of profitability ratios, we have returns on assets, return on equity, which is the return on asset is just the net income or the earnings divided by the average total assets. The return on equity, this is the net income divided by the average equity or the shareholders equity, but it's not included here, ladies and gentlemen. So it means, in other words, we wanted to actually investigate within these factors which are actually included there, what are the major factors like revenue, earnings, price to earning? What are the major factors that are actually affecting this market capitalization? This according to what we wanted to actually investigate, ladies and gentlemen. But we're only gonna perform the EDA, which is exploratory data analysis using Python. Right, in terms of this, here we are going to import the necessary libraries that we'll use to actually uncover the factors that are actually affecting market capitalization. So number one, we'll import the libraries that will assist us in data reading and visualization, ladies and gentlemen. And the first one is something called NumPy. NumPy is one of the most important libraries for data analysis, particularly in Python. Right? If you have not if this is the first time watching my video, there is a video that I've introduced, which is called Introduction to Python. So you can watch my videos in actually understanding more of Python in terms of its libraries. Now we'll import NumPy. So I'll just import NumPy libraries. Import NumPy as NP, and also will import pandas. Pandas library as PD. The pandas library is a library that we're going to use in order to read data, particularly if the data is in a CSV format or in an Excel spreadsheet. Then again, we'll import the libraries that will enable us to help us in data visualization. And the first one is called the matplotlib. Matplot library. So we will import matplot library.py plot splt, and also we'll import another library called the Seaborn. Seaborn is one of the most important library for data visualization. We just call it as an SNS. And again, we'll also import the library, the warning library, which will just suppress some of the warnings that, like when we are going to, when we are doing the data analysis, just not to display some of the unnecessary warnings. So we'll just import warnings. Then after importing these warnings, then we'll say the warnings dot filter warnings. Then we want to ignore all the unnecessary warnings in our data analysis. Let's now run this. So we have imported the necessary libraries that we want to use for data visualization, ladies and gentlemen. Then after that, we need to actually import to read the McDonald data set. And this McDonald data set is actually in a CSV file. So we're going to read this McDonald data set, which is actually in a CSV file. So what we'll do here, we'll just create a file path. So in the meantime, while it's still running, okay, it's completed. Let's just create a file path. Then after creating a file path, we'll just say data equals to, actually, there's no need to create this file path. We can just say data equals to, then we call this pandas library. So it's pd.read. So we actually wanted to read a CSV file. So it means says read._CSV file, but in a quotation mark. Then we need to actually call the path file path. Let me just go and call the file path. Here it's my file path, the McDonald file path. Let me copy the file path. Then now I'm gonna paste this file path here. You see, I've pasted the McDonald financial ratio file as a CSV file, but must be in quotation marks. So we're going to read this. Let's read this. We used pandas. You see, it has already read the data set. Now let's proceed. Let's now display the first 5 rows of this data set. And using Python, we are going to use something called the head. So it's going to be dataset.head as a function. So let's print this. Printing this, it will actually it will show us the data set. So when you look here at the data set, we have the year column, the market capitalization in $billion, the revenue, the earnings, the price to earnings, price per sales, price per book value, operating margins, earning per shares, and the last column is the total liabilities. And by looking at this, if you look at the year column, the years are actually not arranged in ascending order. You see, this one is 2022, 2021, 2020, 2019, and 2018. You see, this already, it has been arranged from highest to lowest. So now, which means we need to make sure that the years, it's arranged from the minimum to the maximum, which we're going to look at that later. Then now let's proceed. Let's now display the last 5 rows of the data set. In Python, we use something called tail. So it's going to be data.tail. So this one will actually display the last 5 rows of the data set. So you see that the last 5 rows actually, it's from 2002 up until 2006 in terms of the years. So this is actually the financial ratios of the McDonald data set. Now again, we want to create a list of all the futures that are in this data set. And to do that, we're going to use function called data.columns. But data.columns actually will give us all the futures which are used here. If you see here, we have the years, the market capitalization, the revenue, the earnings, the price per earning, but we need to we do it as a list. And to do that, it means I will use function called list. So I'm listing all the futures. I'm actually creating a list of all the futures in the data set. So I've actually created this list. You can see there. The first one is the year market capitalization. The last one is the total total liabilities. Then now we need to sort the data frame. We want to sort the data frame by years, columns in ascending order. So what does this mean? It means if you can check from the data in terms of years, is being arranged from 2022 to 2000 and 2022 to 2002. So we want it to be from 2002 to 2022. So to do that means we need to sort the data by using the year columns in ascending order. And to do that, we're going to say data equals to data.sort values by, we need to sort the values by using the year column. So I'm gonna copy the year column. I want to sort this by using the year column, but in ascending order. So which means I have to set the ascending order, the ascending to be true, because I wanted it to sort from smallest to highest. So now we've created the function. Let's now display the first 5 rows. So we're going to say data.head to check if the data is sorted. So you can easily see that the data is being sorted from 2002 up until to 2022. So it's being sorted from the smallest to the highest, which is fine. But now if you look at the index are not arranged, in, so we have 2019. So let's now reset the index, and we can also drop the index, just assuming that our index will be the yes. So to do that, we're gonna say data equals to data dot reset. We want to reset the index dot reset index. But even though we are setting the index, we want to drop the index. So let's say drop equals to true. So now we have done that. Let's now display our data set, data dot head. So I wanted to check if the index are actually sorted. So you can easily see that the index are already sorted. So we have 0, 1, 2. We no longer have this the index at all. And now let's now check the data types of this data set, whether it's an integer or it's an object type or it's a float data type. So to do that, you're going to use a function called data.info. So data.info will give us the data types of this McDonald data set. So if you can check here, it shows that we have actually each columns has 21 observations. And as you can check, the year it's an integer. Market capitalization is a float with size 64. So float means the values are in decimals. The values are in decimals. And also actually it means it's only the year column which is actually in as an integer, but the others are actually in decimal format. So now this is the information that we actually extracted from the McDonald financial ratio data set. Let's now display the statistical summary of this data set to actually look on the distribution of these data sets. So to do that, we're going to use something called describe, data.describe, but I'm going to use the function t. T is just there to transpose. For example, if I don't put this, let's run this. You see that the columns are actually in, like, they're actually written in a column form. But if I wanted to transpose them, it means I'm going to say dot t, which means I want to transpose those features. So let's run this. So you see now the data, it's now transposed. So actually, let me try to increase this because I wanted to talk about something very important here. Okay, now actually in terms of this, the statistical summary here, we can easily see that when you look at this, from this statistical summary, it's showing the count, how many observations are in the data set. It's actually showing the mean of the data set. What is the average of each data set? And also it's explaining the standard deviation, the mean, the quartile 1, quartile 2, which is the median, quartile 3, which is the upper quartile, and the quartile, the maximum. This has to do with 5-number summary, which we'll talk about. So if you can check here, you can easily see that the market capitalization has a mean of 96. It has a mean of 96.8, whereby its median, which is the 50th percentile, it's actually 90.22. So you can easily see that the mean of the market capitalization is bigger than its median. And we know that when the mean is actually bigger than the median, it shows that the market capitalization data set is skewed to the right. It's actually skewed to the right because the mean is bigger than the median. For example, in terms of the revenue has a mean of 22.7, whereas its median is 22.8. You can easily see that the mean, it's actually below the median. Obvious, if the mean is below the median, it shows that we're having a skewed to the left distribution. And also we can check this. For example, if you wanted to check the earnings per share of this McDonald data set, it shows that in terms of the earnings per share, it ranges from a minimum of $0.70 to a maximum of 10.11 US dollars in terms of its earnings per share. And you can easily see that in terms of the price to earning, 75% of the data set of this company has actually the price per earning is actually 24.8 and below. So these are the things that we will be actually observing in this data set in terms of its statistical summary. And you can easily see that this data set actually has no missing values. It has no missing values, ladies and gentlemen. Let's now continue with the analysis. And for example, if you look at the net asset, the net asset ranges from a minimum of minus 8.22 to a maximum of 16. And the total liabilities of McDonald ranges from 13.54 to a maximum of 60.45 US dollars. You can easily see that this company has a lot of liabilities. All right, then now we can now proceed. Let's now check the missing values in the data set. We're gonna say data dot is null. So this is the function to check for missing values. Now let's just do the summing. The summing here, it will just check this. You see, it shows that the year column has no missing values. Actually, it shows that all the columns has no missing values. So I can also do another summing to sum almost like to check the whole columns. You can see that these columns has no, the McDonald data set has no missing values. And now let's now check for the duplicate in the data set. Data dot duplicated. This is the function to check for duplicates. Dot sum. We want to check if there are any duplicates in the data set. So we can see that there are no duplicates in the data set. Then again, let's create the copy of the original data. And this is one of the most, it's a good practice actually to create a copy of the original data set, so that when we make changes in the data, we do not make changes in the original data set. And to do that, we're going to call our new, the copy of the data, to call it df equals to data.copy. Data.copy. This is the function used in Python to copy the data frame. So now we have copied, now we're going to use the data frame called df. So let's now say, let's display the first 5 rows, df.head. So this is still our data set now. This is our data set, but we just created a copy. Let us now perform the exploratory data analysis. But now the first one, I'll use something called univariate analysis. So it means in terms of univariate analysis, it means now we'll just have to observe, to display the data set, but looking on each column. particularly because here we know we are using numerical columns. So it means we're just going to visualize each column in the data set to actually talk about, like, to actually explore the distribution in terms of its skewness. Then now here we are going to let's create a function to display the box plot and the histogram, which we will call it the box hist plot for this numerical column. So in Python, we're going to define a function using the function called def. So this function, I'm just going to define a function that we'll use to display the box plot. So I'll just call it the box hist plot. Then this box hist plot will need an input data. Obviously, the input data will be my data that we're going to use, and also the variable already here, because it's a univariable, I'll just use one item. Then now from here, number one, we're going to set the size of the plot. So we're going to use plt.figure. Then now I want to set the size. Fig size equals to, let's say, I'll just set it as the width of 8 and the height of 3. Then again, let's now construct a box plot. So we're going to say cbon dot box plot, and we know in terms of the box plot, we just want to display the box plot of each numerical data, so that we are able to look at on its distribution, the minimum, quartile 1, quartile 2, quartile 3, and the maximum. And to do that means you're going to say, okay, fine, our data, the data will just be the data. Then on the x-axis, we'll only display the item that we want to put in there. And again, let's set the title. So we're going to use plt.title to set the title. So I'll just use the f stream. So I'll just use the item. Okay, sorry. So I'll just use the item. No. I'll say the box plot. Okay, apology guys, we're just setting the title of the box plot. So the box, okay, let's just use an f string. So it's going to be the box plot for the item. Let's call this each item. Then again, let's label the x-axis. Going to use plt.xlabel. Label. So I'll just use an f string. I apologize, it's going to be my item. Then let's now show the plot. So going to be plt.show. This is a function to show the plot. Let me just arrange it in one order. Okay, then now this is the function just to show the plot. Then now let's now do the same for a histogram. So I'll just copy this. So it means for histogram, we'll do the same here. Then this one, I'll change it, the function, I'll change it there. The title is the same. I'll just change it. Okay, then the label is the same. The labeling is the same. But now we have to do the y label. plt.y label. Y label, obvious on the y label for histogram, which we need to just put the frequency, and plt.show. And okay, let me just put them in one order. Okay. Okay, just this. Okay, then now means the first function was for this one was for a box plot. This is for box plot, and this one is for a histogram. This for a histogram. Okay, so it means this is just the hist plot. Hist plot. And within this hist plot, we just use the item. Then this is the histogram. It's a histogram for item. Set the title for the histogram. Histogram. And the frequency. Okay, fine. This is what we want because we know on a histogram what you want. On the y-axis means will just be the frequency, the counting. Then on the x-axis means it will be our column that we're actually interested on. Actually wanted to look at the distribution of this numerical data set. All right, let's check if I did not miss anything here. Let me check. I've set the size, box plot title. I've labeled the x-axis, the plt.show figure, hist plot, okay, histogram, everything is fine. Then we have defined it. Let's now run the code. It's fine. Let's now display the box plot and the histogram for a market capitalization. So we only wanted to display the box and histogram for a market capitalization. To do that means I'm going to call this function again. So this will be the box plot, but this box plot in terms of its input, it needs the data and also the item. And our item it will be the market capitalization. So to do that, it means our data will be the DF. But what is our market capitalization data? Let me call the function to display all the columns. So you see, we want just to display for market capitalization only, the column for market capitalization. So what do you want here? I just called the function that I've defined here so that it must display the box and histogram for market cap. Let's run this. Right. When we run this, you can easily see that this is our box plot and the histogram for a market capitalization data. And you can easily see that in terms of this data, in terms of the market capitalization, remember this is the minimum, this is the quartile 1, this is the quartile 2, and this is quartile 3, and this is the maximum. So you can easily see that this is skewed to the right. So it is skewed to the right distribution. So it's skewed to the right distribution. So in terms of this, you can easily see that the maximum market capitalization of this McDonald data set, it's roughly around 200 billion in terms of US dollars, which is with a minimum of less than 25. So and remember we said this market capitalization, we actually calculated by taking the price, the current price, and multiplying it by the number of shares. But we actually we're going to look on the other factors that can affect this market capitalization, right? Then again, let's now display the box plot and the histogram for the revenue column. So we only wanted to observe the revenue column only. And to do that, so what I'll just do here is we wanted to display the box and histogram for the revenue column. And our revenue column is this one here. Let me call it, because we are using the same data set here. So I'll just paste the revenue column. So wanted actually to look on the observation. Okay, apologies. Let's do the running. Let's run this. So you can easily see that the data set for the revenue, actually it is approximately, we can just say it is slightly skewed to it's approximately symmetrical. It is approximately symmetrical, where the mean is approximately the same as the median. So if we go back to our statistical summary, we just want to observe the revenue data set. The revenue, like the revenue column, the mean is roughly around 22.7, and this one the median is 22.8, which is slightly, it's actually slightly symmetrical, but however the mean is less than the median. So this is what we actually has observed. So now let's continue with our data analysis. And then now let's compare, let's display the box and histogram for earnings column. So it means for the earnings column, I'll just call this function again. I'll just call this function again, but this time around, we just want the earning column. We just want the earning column. I apologize. Where's the earning column? The earnings column is this one inside the list. I had copied it. So let's now run this. So let's run. We wanted to display the box and histogram for the earnings. So you can easily see that in terms of the earnings, the distribution is skewed to the left. The distribution is skewed to the left. So we have a skewed to the left distribution, which is actually the same as saying negatively skewed. So the earning data set, it's negatively skewed with a minimum of less than $2 billion and with the maximum, which is above 9. So this is the earnings of the McDonald data set. So we're just analyzing it here now, and you can easily see that in terms of these earnings, between the earnings, so it means they like some earnings that are ranging between 4 and around 5. So it shows these companies does not have such data. So this is what we actually got here. Then now we can now proceed with our data analysis. Now the next one, it says we need to display the box plot and the histogram for the price to earning ratio columns. And to do that, I'll just copy this function here. The only thing, I'm just going to change the price to earnings. So it means the price to earnings, I think it will be, so let's go to the function and try to copy it. So this is the price to earnings. This is the price to earnings. I'll just paste it here. Okay, we just want to display the box and histogram. You see, this is the price to earnings, which shows that there is a skewed to the left distribution. So the price to earning ratio, it's skewed to the left with a minimum of around 15 and with the maximum that is above 32.5 in terms of price per earnings. And now let's now, to avoid displaying all the futures one by one, let's now want to create a list to display actually all the remaining columns at once. So the remaining columns. So we create a list to select the remaining columns. So I'll just say the num column. So let's just call it the num column. So yeah, I actually wanted to create a list. Already we used the market cap, we used the revenue, went through the earnings, price to earnings. So we can now visualize from this one up until the last one. So either we can just copy the remaining ones, we can just create a list of the remaining ones. So to do that, let me just create a list. Now I'm gonna paste that. You see, I just created a list to select the remaining columns because already we have visualized the price per earnings, revenue, and market cap. So after doing this, okay, let me just run this. I'll just run this. Then now let's create a loop to display the box plot and the histogram of the remaining. What do, we wanted to select, to say in every element or in every future that is inside this numcol, we want to display the what? The box and histo plot. And to do that, ladies and gentlemen, we are going to use a for loop. We'll use a for loop. Okay, I apologize. Let's use a for loop to say for any item that is inside this num column, this one. For any item that is inside the num column, we're using a for loop. We want to display the box and the histogram at once. And to do that, so I'll just paste the function here. So, and to do that means here, I'll just say item. Let me explain this. How is it going to do this? What it will do to say within this list that we have created, it will take every item inside this. So if it's this one, then it will substitute there and display its box and within just up until the last one. So at once. So we can now run the program. Let's run the program. You see it has now displayed the price to sales ratio. You see skewed to the right. And the second one, it's priced per book value, operating margin, earning per shares that are outstanding. Then the other one is the cash on hand, dividend yield, and the net assets, total assets, total debts, which you can see that this is skewed to the right. And again, we have the total liabilities. So it has displayed all the box and the histogram of all of the remaining futures. Now, let's now move on to the next part. Here, we actually wanted to display a line plot for each column. And it means what do you want to do here? We actually wanted to draw the line plot for each column. For example, if we were to compare the, to look at the price per earning, maybe on every year, what is the line function? What is actually the trend for price to earning? So we wanted to observe that. And to do that, ladies and gentlemen, we're going to create a function to display the line plot of each column per year. And to do that means, what does it mean? We're going to say, okay, fine. We define a function. Let's call it a line plot. And this line plot, in terms of the input, it needs a data. And within the data, remember, I want to display the line plot that will need the x values and the y values. So already the y values will be our futures, and the x values will be the year. So already here we know that one item already it will be the year. So it will be the year, and the other item will be the column. So let me just call it the item here. So now to do that, let's set the size. So actually, let me just copy our function, the one we have created earlier. Let's just make a copy of the function that we have created earlier, ladies and gentlemen, so that we can save time. So in terms of our analysis, I'll just copy this. Yeah, let me just copy up until here. Now I'll paste it here. Let's paste, there's gonna be, sorry. Okay, first, okay, the size is the same. It will not be a box plot, it will be a line plot. So line plot. And within this line plot, what do we need? We need the x values. The x there will be the year. The x will be the year. And what is the y value? Y column, I mean to say, y column will be an item. The y column will be, because on the x-axis we want the year, and on the y-axis we want the y value. Construct a line graph. Then now let's give the title. So this is the line graph for our item that we are the line graph for our item. Then on the x-axis already we need to label the x-axis, because by the way, guys, we need to label both the x-axis and the y-axis. By the way, on the x-axis will be the year. The x-axis will be the year. So I'll just put the x-axis here. We'll just put the year. So also have to label the y-axis. So it will be plt.y label. So just create an F string. So inside there, I'll just put the item. It means on the y-axis, we just want to put the item. Then now we've created the function, ladies and gentlemen. Let me check it for the last time before we run it. So the line plot, figure, line plot, x and y, title, x labels. Okay, fine. Let's now run the function. So now here it says select a list of the independent variable and call it futures. So I wanted to select a list of the independent variable. Let's just call it the futures. Obviously, the independent variable here will be this variable, but excluding market cap, because market cap is the target variable. Already even the year, because not what we want to, the year will be on the x-axis. So I'll just copy these ones only. Let me copy this from revenue up until the, so let me just create a list. So this is the list. Let's run this. So now, first of all, it says, let's display the line plot for the market capitalization. So here we wanted to compare market capitalization per year. And to do that, it means, remember I said on this, we need the data, the year, and our item. And to do that means I'll just copy the function again. Let's copy the function here. We call it a line plot, which require a data. And on the x-axis, we want to display a year column. It means the year column will not change. So let me just copy the column. Where is it? Okay, let me just say df dot columns. So the year column is this one. We'll just copy the year column. And then now the year column. Then again, we need, remember, we need the year and the item. The item is what we're interested on, which is the market cap. So it means here it's our market capitalization. So I'll just plug it here. So let's now display our line graph. So let me just try to increase the size of this. Let's say the width is 8 by 5. Let's increase the size so that we can see it well. Let's increase the size so that we can see it well. So you can easily see that this is our line graph for the market capitalization, ladies and gentlemen. And you can easily see that from 2002 to 22, there was actually an increase in market capitalization. But the one that is the highest market capitalization, it's actually between 20 up, I think around 2021. So the maximum capitalization, it was actually in 2021. You see that there's an increasing trend. There is an increasing trend in terms of the market capitalization. You see that it's actually increasing, but actually in some years, there was actually a decrease. The market capitalization was at its minimum, like around 2016, if I'm not mistaken, ladies and gentlemen. So there is an increasing trend in terms of market capitalization, ladies and gentlemen, which actually is a good sign that McDonald is actually performing well. It's in terms of its value, because it shows that there's an increase in stock price. Right now, so we actually wanted to check what are the actual factors that are actually affecting this market capitalization. So now to do that, let's create a for loop to actually display the line plot for each column of the remaining columns. Actually wanted to actually observe the market capitalization of the line graph for revenue, earnings, price per earning. And to do that, to avoid displaying each column, so just create a for loop to say for every item that is inside the future list, inside the list that we have created there. Remember, we created a list, so we wanted to iterate through every column here, so that we're able to display the line graph. So I'll just copy this function here. Remember, we know that on the y-axis, on the x-axis, the year, on the x-axis, it will always be the year. So what we're gonna do here, we'll just say we put the item here. So what it will do, it will just say, it will just pick every item that is inside the column that we have created, then it display the line graph of each item. Let's now do that. Let's now display. So for example, if you look here, it has displayed the line graph for the revenue. You can easily see that from 20. Okay, let me just try to decrease the size. At least we can be able to visualize it well. Just a minute, guys. But it's fine. Let's just go through it. It's not that visible, okay? No, it's fine. It's fine. Okay, let me just do this. Let me just try to decrease the size. Okay, let me just decrease the size, maybe 8 by 3. 8 by 3. Let's run this. Let me run this code again. Okay, you can easily see that the revenue the line graph for revenue from 2002, it had the maximum revenue in just around between 2012 to 2015, just around 20 in the year of 2013. It has the maximum revenue, but with the minimum revenue in 2020. And we could wonder what could be the possible reasons for that. And then now it shows that in 2020 it had its revenue actually has decreased as compared to other years. And then now and there are a lot of factors that can cause a decrease in terms of its revenue. Let's look at the earning. The earning also it has an increasing trend, but even in 2020, it had a minimum earning. Then also the price per earning. The price per earning from 2002 to 2005, it has a decreasing trend. It had a decreasing trend, but however, from around 2006 and onward up until 2007, it had a sharp increase up until it had a maximum price to earning within 2005 and 6. Then after that, it decreased sharply. Then in some years, it gradually increases up until around 2020. The price to earnings become the highest. And why is the price per earning in 2020, particularly in 2020, why is it the highest? Is because remember we said the price to earning. It shows that in 2020, remember from the previous line graph, the price to earning was at a minimum. It has decreased in 2020, and by that time it means, remember when we have price to, if this one decreased, means it causes the price to earning to actually do what? Increases. So that is the possible reasons why the price to earning in 2020 was actually the highest. Is because its earnings in 2020 was very low. Remember, the lower the earnings, the higher the price to earnings. So they're inversely proportional. All right, then now we can now continue with the analysis. Then now, again, looking at the price per sales is having an increasing trend. Price per book value, in some years it increased then, but just around 2015, it decreased up until to its minimum value, which happened roughly around 2016, if I'm not mistaken. Then again, we have the operating margins, which actually have an increasing trend, but it had a minimum percentage, particularly in 2020. And what could be the problem? Remember, operating margins has an impact towards it's affected by the earnings. That's why it is also in that. Also, we have the earnings per share. The earnings per share also is affected by the earnings. You see, in 2020, it was having the minimum. Why? Because earnings per share is calculated by taking the earnings divided by the outstanding shares, the number of shares outstanding, number of shares also. You see, because the earning in 2020 was at its minimum, it affected the earnings per what? Per share also. So that is the reason why the earning per share it is at its minimum in 2020. All right, then now again, also the shares outstanding they're actually showing a negative relation. It's actually decreasing. And again, the line graph for cash on hand, you see that in some years, the cash on hand was at its maximum. But in some years, roughly around between 2017 and 2019, the cash on hand was just stable. It was just stable. Then now also the issue of dividend yield, net assets, total assets in the company, for total debts. You can easily see that this company, its total debts are at its maximum actually around 2020. Just around 2020, the company was had a lot of debts in it. So it's actually having a lot of debts in around just after 2018. The total debts actually increases. And you can easily see that total debts in 2020 was at its peak. You see, it shows that in 2020, the company was not actually performing well. It was actually relying heavily on debt. It was relying heavily on the liabilities. So it means in terms of something called financial leverage. So it means now we'll say the company has had the highest financial leverage actually in 2020. All right. Now, again, we can now proceed. Now here we wanted to display the scatter plot between the variable. So this is an example of a bivariate data analysis. So this is a bivariate data analysis. So what we want to do here, we wanted to compare the relationship between the market capitalization and those futures to check if there is a correlation between the market capitalization and the future. For example, market capitalization and the revenue, is there an increasing trend or is there a decreasing trend? So that is what we want to do here. So here we are going to create a function to display a scatter plot. So I'm going to say definition scatter plot. I'm defining a function. And within the scatter plot, what do we need? We need the data. We need the data and we need the variable. So we're going to call it item 1, the independent variable, and the item 2. So we need the item 1 and item 2 to display. Remember, we wanted to compare the relationship between market capitalization and maybe revenue or even the earnings or the others. So that's why we need 2 variables. So now to do that, it says create a scatter plot between the target variable, which is the market cap, and the independent variable. And we must set the palette as deep. So this is just the color. So we're gonna do this. I'll just copy the function that we created earlier. So just copy this. Let's copy the function, ladies and gentlemen. So just paste it there. So figure size is the same, line plot. This will not be a line plot, it will be a scatter plot. So we want a scatter plot. The x-axis will be the item 1, and the y-axis will be item 2. It means our y-axis will be the market cap. So this is the line graph. It's not the line graph, it's the scatter plot. So when I say the scatter plot of item 1 and item 2. So I'll just say, remember item 1, let's just say item 2 and item 1. Okay. Title for the scatter plot. Then on the x-axis, what do you want? It is the x-axis. What is this? The x-axis is the item 1 on the x-axis, and on the y-axis is item 2. Then plt.show. Or they said we must set the palette as deep in terms of its color. Okay, let's just say palette as deep. So this is just the color. Then now let's run the code. It says unexpected. Okay, let's do this. Okay, it's fine. In terms of function, let's run it again. Now it's okay. Then the first one says construct a scatter plot between the market cap and the revenue. So here we wanted to just display the market cap and the revenue. So I'll just call the function. By the way, the data is our df. On the x-axis, we need to put the revenue. So I'll just put the revenue column. Where is our revenue? Okay, let me just display those columns. Df dot columns. So on the x-axis, we want the revenue column. And item 2, it's our y-axis. So it will be the market cap because we wanted to construct a scatter plot between the revenue and the market cap. Let's run this. So you can easily see that here there is a positive correlation between market cap and revenue, but however, you can see that the points are actually scattered. So you see that there is a very weak correlation between market cap and revenue when you look at the scatter plot here. And then now let's now create a loop to display the scatter plot at once. So we're gonna do this. We're gonna say for item in our columns. By the way, ladies and gentlemen, wanted to display a scatter plot, but by comparing, or we just copy the whole future, all the futures actually. So it's all the futures. So what we're gonna do it, because already we have displayed that one for a revenue. So okay, it's fine. Let's just use all of them. So do J for future. Then let's now display a scatter plot on each between the market cap and the independent variable. And to do that, we'll just put an item here. So it's item. Let's display the scatter plots for all the data. You see now here it's about revenue and revenue and revenue. No, we're not comparing this. Let me. Yeah, by the way, the market cap is the same. I apologize, guys. The market cap is the same. So we actually wanted to observe between the futures and the market capitalization. Okay, let me just copy this. I apologize, guys, because now it's actually one between the independent variable. So let's just put the item here. So it's item and the market capitalization only. Let's run this. So you can see that here it's actually comparing the independent variable, the market cap. The first one we went through is the issue of market cap and revenue. Market cap and revenue, that's the first one. Market cap and earnings. Market cap and price to earning. Market cap and the price per sales. Market cap and price. You see, it shows that there's no correlation here. If you look at the scatter plot between the market cap and the the price per book value. It shows that there is no correlation between the market capitalization and price to book value, because if you look at this, you see that it shows actually you can just say there's a negative correlation between the market capitalization and price to book value. Then now we can continue with the analysis. Then when we look at the scatter plot between the market cap and operating margin, you can easily see that there's an increasing trend. It shows that there's a positive correlation between the market capitalization and the operating margin. There is a positive correlation between the market capitalization and the operating margin. Then let's look on even the market capitalization and the earning per share. You can easily see that the relationship between the market capitalization and the earning per share, there is also a positive correlation. There is a positive correlation between the market cap and the earning per share, which means this might be one of the factors that can actually affect the market capitalization. Ladies and gentlemen, remember the objective is to uncover factors that can affect market capitalization. So again, we can also observe, you see, between the market capitalization and the shares outstanding, you see that between the market capitalization and the shares outstanding, there is a negative correlation. There is a negative correlation between the market capitalization and the shares outstanding. So it means there is a negative correlation between the market capitalization and the shares that are actually outstanding. Now we can proceed, look at the market capitalization and the cash on hand. If you can look at this, the data is actually scattered around. So we can just say there's a slightly positive correlation, but it seems like there's an outliers within this data. Things like this is an example of an outlier, because it's the point that is far much away from the other. So it's regarded as an outlier. So like we'll also look on the other quantities that will actually assist us in explaining or explain the correlation between the market capitalization and the other factors. For example, if you look at the market capitalization and the dividend, actually there is a slightly positive correlation. There is a slightly positive correlation between the market cap and the dividend yield. However, but it seems like there are some outliers between this, which we'll talk about that. Then again, let's now look at this. If you look at the market capitalization and the dividend stock in terms of the stock yield adjusted, it shows that there is a positive correlation between the market capitalization and the dividend yield. So it means that if we were to assume this, we'll say if the dividend yield are increasing, it means the market cap will actually increase, provided other factors remains the same. And now, actually, if you look at the relationship between the market capitalization and the net asset, it shows that there's a negative relation between these two. And also total asset, there's a positive relation between market cap and total assets, total debt, and also total liabilities. So if you can look at this, it shows that there is a positive correlation actually. There is a positive correlation between the market capitalization and the total liability, but we will not actually quantify whether, even though we know that there's a positive correlation. Will not quantify whether it's very strong or it's weak or it's moderate. We'll actually calculate things like something called correlation matrix, which will actually give us the like it will quantify the strength between the market capitalization and our future variable or the independent variable. Remember here, we actually wanted to look on at the factors that can determine market capitalization. And to do that, yeah, guys, we just create a list of the data set that will use to construct something called a correlation matrix. Correlation matrix actually is going to calculate the correlation between the variable. And actually, the correlation between the variable is calculated by using the following formula. So correlation, this is a symbol for correlation. Correlation between X and Y is calculated by using the covariance between the X and Y and divided by the standard deviation of the X and the standard deviation of the Y. And this correlation coefficient ranges between -1 and 1. So which means if the correlation is negative, it shows that there's a negative correlation between the variable. And if it's positive, it shows that there's a positive correlation. Actually, it's just a unit. That is actually is the method that we use to quantify the relationship between two variables. And to do that, it means we wanted to calculate the correlation between the target variable and also the independent variable. So here is just the list of the features that we want to look at. Then let's calculate the correlation matrix. And to do that, we'll just call it the correlation matrix. So which will just say the data. Then we just include all the features that we wanted to look at. I did not include the year column because it will not assist us in calculating the correlation. So I'll just say correlation. This is the function to calculate the correlation. Let's now print the correlation matrix. So I'll just print correlation matrix. It's actually calculating the correlation between the variable. So you can easily see that, okay, let me just try to increase this. So you can easily see that this is the correlation. Here it's actually comparing the correlation between variable. It started with the correlation between market capitalization and market, it says it's 1 already. The correlation of a matrix itself will always be 1 because the correlation of X and Y is the covariance of the X and Y divided by the standard deviation of X and the standard deviation of Y. So which means if you wanted to calculate the correlation between X and X, this will be the covariance between X and X divided by the standard deviation of X times the standard deviation of Y. And we know that the covariance actually, I apologize here. We know that the covariance of the covariance of the same asset is the same as the variance, is the same as the variance of that asset divided by the standard deviation times the standard deviation. And what is the variance? The variance actually, it's sigma squared, which is the variance. So it means is the square of the standard deviation. So it means this is the same as sigma x times sigma x over sigma x times. That's why this is dividing and this gives us 1. That's why the correlation of an asset itself will always be 1. For example, correlation between revenue and revenue will be 1. So that is the information that we got here. But if you can observe here, the correlation between this is not actually showing well because it's just showing it's not a complete information. So you can easily see that some of the variables are positively correlated and some are negatively correlated, which we'll talk about later in terms of something called multi-collinearity. But just here, we just want to visualize. So to do that, ladies and gentlemen, we're going to display something called a heat map. The heat map will actually display this correlation matrix in the form of a two-way table, and we're going to use that. So here we're just going to display a heat map and set the color to blue. Okay, fine, let's do that. Let's set the size. So just let me just copy the function that we created earlier. Let's copy the function that we created earlier. So we've seen that some of the variables are not correlated with the target variable. So let me paste it here. Okay, fine. And we want to display the heat map. Obvious needs here. There is no need. Okay, there's no need for the X label and the Y label. Yes, we can put the title. The title is just the correlation matrix. Let's just call it the correlation matrix. Then we do not want, we want a heat map. So the heat map will just be heat map. Then what do we want? We want the data. And what is our data? The correlation matrix that we have calculated here. So I'll paste it here. So we want the minimum, the V minimum to be -1, the V maximum to be 1, and we want it to display the value. So R naught equals to true. Then again, true, then we want the color. Let's say C map should be in blue. C map should be in blues. Okay, we have created the, okay, let's just increase the size. Okay, it's fine, we'll just increase the size there. Let's run this, let's run the program. Wanted to display the correlation matrix. So wanted to display the correlation matrix. You see that is not that, okay, let me just say PLT or layout. Okay, tight layout. So the layout is not that visible. Let's just say tight layout. Okay, let's increase the size. Let's increase the size. Okay, let me not say, okay, fine. Let me not say tight layout. Let's not increase the size. I want to check something here. Okay, let's increase the size, maybe 15 by 10. I just want to increase the size, 15 by 10. Okay, then now you see, okay, fine, let me just try to reduce it. Let's say 10 by 10. Right, if you can check here, this is our correlation matrix. However, it's not showing the correlation between the other. But now what are we interested here, guys? We are interested on the looking at the correlation. Okay, let me just do this. Let me just PLT dot tight layout. Okay, let me type the layout. I want the layout to be tightened. Okay, right, look at these guys. Maybe we can decrease the size, but it's fine, it's okay. It's fine. Look at this. Here we are comparing the relationship between the target variable. What is our target variable here? Our target variable is the market cap. And within this target variable, this is just, if you can go down here, I want to show you something. Remember, this is price to earning. So it's price to earning, revenue, earnings, and so forth. So here, it's actually showing that between, okay, can I decrease the size? Okay, let me just try to decrease the size. Let's say we have 8 here. I want to see something. Okay, I think you can see it now. I've just decreased the size. What did I increase here? So it means the width. Okay, let me just say 8 by 8. It's fine. Let me just increase it. It's fine. 10 by 9. Let's increase the size. Okay. Now, if you look at these guys, this is actually, it's actually comparing this. Let me just explain here. In terms, this is our target variable, guys. But here it means this is the market cap here. This is the revenue. This is our revenue. This is the earnings. This is the price to earnings. This is the price per sale, price to book value, and which means you can see that the correlation between market cap and market cap is 1. The correlation between the market capitalization and the revenue, it's roughly around 0.3. You see that it shows that the correlation between revenue and market cap is 0.3, and 0.3, it shows that it's a positive correlation. It's a positive correlation, but it's very weak. There is a weak positive correlation between the revenue and the market capitalization. And again, if you look at the correlation between a correlation between, what is this, the 0.78, the 0.78 and market cap. What is this one? 0.78, it's earning. So it shows that there is a very strong, there is a strong, not necessarily very strong, but there's a strong positive correlation between earnings and market capitalization. And also there is a positive correlation between the price to earnings, this price to earnings, and the market capitalization. But if you look at the correlation between market capitalization, the correlation between market cap and what is this one, and the price per sale, it's roughly around 0.97. So this shows that there is a very strong positive correlation between market capitalization and the price per sale, which means price per sale has a huge impact towards market capitalization. But however, when we look at the relationship between what is this, between price to book value and the market capital, because this is just price to book value, the correlation between price to book value and market, it's around -0. So it shows that there is a negative positive, I'm saying there is a negative correlation between market capitalization and the price to book value. And again, if you look at the correlation between market capitalization and the operating margin, it's around 0.88. There is also a very strong positive correlation. And also there is a very strong positive correlation between earnings and market capitalization. And also there is a very strong negative correlation. There is a very strong negative correlation between the shares that are outstanding and the market capitalization. And also there is a weak positive correlation because this is around 0.32. There is a weak positive correlation between cash on hand and market capitalization, and the correlation between market capitalization and dividend yield, it's around 0.97. It's also showing that there is a very strong positive correlation between market capitalization and dividend yield. And some of this correlation might be the cause of, remember, some of this is because, for example, when you're calculating dividend per earning, dividend yield, we use earning. You see that because of between the market capitalization and the earning, there's a very strong, this one, it's some of the reasons why some are already highly correlated. And again, there is a positive correlation between the dividend in terms of stock splitted and the market cap. And also there is a very strong, actually, there is a very strong positive correlation between net asset, total asset, and total debt, because the correlation is it's above 0.8. So it's roughly 0.9. So you can easily see that majority of these futures are highly correlated with the market capitalization. They are highly correlated with the market capitalization. So which means that, however, because remember the issue of some of the independent variables are actually auto-correlated. They are auto-correlated, and this might be the problem of something called the multi-collinearity issue, and which we will talk about that. But however, for now, we can say majority of the driving factors, the factors that are having a major impact towards market cap would be things like earnings, price to earnings, price to sales. However, price to book value, but with the price to book value, there's a negative correlation. And the other one, what is this? There's a very weak positive correlation between, what is this future here? Between the cash on hand and the market, because it's around 0.098. You see that it shows that there is a very weak correlation between cash on hand. It shows that cash on hand has no impact towards market capitalization. So it shows that majority of these futures has an impact towards market capitalization. But however, the issue of correlation, we cannot heavily rely on it, because in terms of correlation does not imply causation. Correlation does not imply causation. Correlation does not imply causation. So it means just because we have a strong positive correlation between the market capitalization and our future variable, this does not mean that this future variable is the cause of this market capitalization. correlation does not imply the cause. So for example, because there's a strong positive correlation between market capitalization and earning, it does not mean that the earning is the cause of market capitalization. It just shows that there's a very strong positive correlation between market capitalization and earning, but correlation does not imply causation, ladies and gentlemen. So it means in the next video, we'll actually taking it further to analyze to actually investigate what are actually the exact determinants of market capitalization in terms of our analysis, ladies and gentlemen. So we have visualized, we have analyzed the McDonald data set. We looked at its distributions, and also we look at the correlations, and also we have done some data cleaning, which is one of the most important part when you are in data science. So when we are given data, to be able to read the data, to actually analyze it in coming up with the informed decisions, ladies and gentlemen. Thank you very much for listening. If you want to learn more about the data science, kindly watch my videos. There's some links that I actually shared. If you use them, then you'll be able to understand most of the things that I've actually done. Thanks for listening. Take care and bye-bye.